Today we're going to cover, we've already covered parallelograms, and that's a quadrilateral, but we're going to cover all the other quadrilaterals that we deal with. And remember, a quadrilateral is a four-sided figure. Also has, not only does it have four sides, it's got four angles. We've already covered parallelogram. Just to go back over this real quick though, properties of a parallelogram. They tell you a shape is a parallelogram, then you know opposite sides have to be parallel. So opposite sides have to be parallel. So these two sides are parallel, these two sides are parallel. You also know opposite sides have to be congruent. So this side's congruent to that side, this side's congruent to that side. Opposite angles, remember opposite angles are angles that are across from each other. So those two are congruent, those two are congruent. Consecutive angles means whether it's these two angles that are just one's right next to each other, one right after the other, or it could be up and down this way, but they have to add up to 180. They have to be supplementary to each other. We draw in the diagonals. Remember that the diagonals are not always congruent to each other. They're not always the same length, but we do know that this is the midpoint of both of them. And these two segments are congruent. These two segments are congruent. And then we also know that all four angles, and this works for every shape that we're going to do today, all four angles have to add up to 360 degrees. And that's for any quadrilateral. To prove something is a parallelogram, I only put three of them on here. This is just going back over stuff. The first one says both pairs of opposite sides. So in that first blank, both pairs of opposite sides are parallel. If you can prove both pairs of opposite sides are parallel, then it has to be a parallelogram. Number two, both pairs of opposite sides are congruent. If you can prove both pairs of opposite sides are congruent, then it has to be a parallelogram. Parallel, let's go back to this first one. Slopes, remember if they have the same slopes, so if we're on a graph, if they have the same slopes, then two lines or two segments are parallel. This one we might use the distance formula on if we were on a graph. Then the third one, both pairs of opposite angles have to be congruent. Again, there's a whole bunch of ways to prove something is a parallelogram. Those are three of them. Just if you see those things, then you know that it's a parallelogram. Now, some of the other four-sided figures that we're going to talk about. First one, a rectangle. Properties of a rectangle, and I didn't list all these out, but all those properties that we just listed for a parallelogram are true for a rectangle. So opposite sides are congruent, opposite angles are congruent. Diagonals bisect each other. Opposite sides are parallel. All those properties of a parallelogram work for a rectangle also. So they tell you a shape is a rectangle, then all those same properties work. And also, remember, the only shape that, the four-sided figures that we're going to talk about today, the only shape of all those four that have a symbol is a parallelogram. So when you're naming a rectangle, if I was going to name this rectangle, I just have to name it rectangle, and then I go around it in some kind of order. Maybe N, T, H, S, but you have to write out the word rectangle, and that's the way with all of them. You have to, if it's a square, a kite, a rhombus, so on, you have to write out the word in front of it. For a rectangle, all angles are congruent. So not only are opposite angles congruent, but all angles are congruent, and they all have to be right angles. So all these angles have to be right angles. And then the diagonals, not only do the diagonals bisect each other, so not only is B the midpoint of all four of both these diagonals, but all four parts are congruent. And the diagonals are congruent to each other. So the length from N to H is the same as the length from T to S. That works in a rectangle. That doesn't work for all parallelograms. Rectangle is one of them it does work for. So that's a rectangle. So you've got quadrilaterals, could be a parallelogram, could be a rectangle. Properties of a rectangle again. We just went over these. So it is a parallelogram. It's got four right angles. Diagonals are congruent. Ways to prove something is a rectangle. First thing you do, you prove it's a parallelogram, whichever one of these you're doing. If you can prove it's a parallelogram, then you check to see if it's a rectangle. If it has a right angle, then, and it's a parallelogram, then it has to be a rectangle. If it's a parallelogram and the diagonals are congruent, then it has to be a rectangle. So two ways to prove something is a rectangle. For this first one, we might use the slopes. Remember, slopes, if we're looking at this rectangle and we find the slope of this side and the slope of this side, if they form a right angle right here, then their slopes are opposite reciprocals of each other. In other words, if you take something like 3/4, the opposite reciprocal of that, you flip it over and you change the sign, so it'd be -4/3. The diagonals, if you can prove the diagonals are congruent, well, that we might use the distance formula. Find the lengths of those diagonals, and then we can say that parallelogram, if the lengths are the same of the diagonals, then that parallelogram is a rectangle. Properties of a rhombus. Rhombus, next shape. All properties of a parallelogram. Again, a rhombus is a parallelogram, so it has all those properties. If I name this shape NTHS, then when we go to name this, we would name it rhombus NTHS, going around it in some kind of order. Again, no symbol for a rhombus. In a rhombus, and these properties, I don't expect you to have them all memorized, but I do expect you to have these notes so that you can refer back to it. If I tell you this is a rhombus, then we know all four sides are congruent. Not only do we know all the properties of a parallelogram, but all four sides are congruent. And then for the diagonals in a rhombus, these two are sort of important. If you have the diagonals, if I draw in a diagonal here, it bisects this angle. So this angle is congruent to that angle. Not only are those two congruent, but they're also congruent to these two down here. And if I draw in the other diagonal, this angle is congruent to that angle. It's being bisected, and they're both congruent to these two angles down here. So the diagonals bisect each of the four angles. And then the diagonals are perpendicular to each other. So not only do these diagonals bisect each other, but where they come together in here, they form four right angles. Which means anytime you have a rhombus and you draw in the diagonals, you have four right triangles. And we can use Pythagorean theorem and all that other stuff on it. So all four of these angles in the middle here have to be right angles if it's a rhombus. To prove something is a rhombus, again, we know all the properties. To prove something is a rhombus, first prove it's a parallelogram. So if it is a parallelogram, we're always going to check that first. Then we look at consecutive sides. That means like this side and this side, sides that are attached to each other. If those consecutive sides are congruent, then the shape has to be a rhombus, if we know it's a parallelogram. The other way to prove it's a rhombus, if we draw in the diagonals, and these diagonals form right angles in here, then it has to be a rhombus. First, again, for all these, each of these shapes, you first have to prove it's a parallelogram. Then you can do all this other stuff. Square. Square is the next shape. Still got all the properties of a parallelogram, so all squares are parallelograms, just like rectangles and rhombus. All properties of a rectangle. Square doesn't have any of its own properties. It gets all of its properties from these other three shapes. So all those properties that we've covered so far for parallelogram, rectangle, and rhombus, they all work for a square. So opposite sides are parallel, opposite sides are congruent. From a rhombus, all four sides are congruent. From a rectangle, all four angles are right angles. And that makes this a square is a regular quadrilateral, because all four sides are congruent and all four angles are congruent. So it's a regular quadrilateral. The diagonals bisect each other. From a rectangle, the diagonals are both, so this length and this length are exactly the same. From a rhombus, the diagonals form right angles in here. They're perpendicular to each other. All those properties that we covered before this one fit for a square. So all the properties of a square, to prove something is a square, first thing you're going to do is prove it's a parallelogram. Once you know it's a parallelogram, you check to see if it's a rectangle. If it is a rectangle, then you check to see if it's a rhombus. If it's both a rectangle and a rhombus, then it must be a square. So you prove it's a parallelogram, prove it's a rectangle, prove it's a rhombus. The best name for it is a square. All right, now the last two shapes. Last two shapes are sort of, I don't want to say they're oddballs, but rectangles, rhombus, squares, they all sort of fit together. Parallelograms. The next one's a trapezoid. A trapezoid is a four-sided figure, quadrilateral, with exactly one pair of parallel sides. Now, in the U.S., that's the way we say it. A lot of countries, other countries around the world now, say at least one pair of parallel sides. So when they're looking at it, and we're going to look at a thing here in a few minutes that I'm going to talk about this, but instead of exactly one pair, everybody else in the world says at least one pair. So they sort of put trapezoid in with parallelograms and rectangles and rhombus and squares and stuff. And we'll talk about that. So a trapezoid is going to be something what we normally think of as a trapezoid is this. These two sides are parallel, the other two sides are not parallel. So unlike a parallelogram where these two sides are parallel and these two sides are parallel, it's just that little bit of difference. So trapezoid, when we name it, again, go around it in some kind of order. So trapezoid DABC, these two sides are parallel. The parallel sides are called the bases. So a lot of times they'll say like base 1 and base 2. Doesn't matter which one they are, but those are always the parallel sides. The other two sides are called the legs. And the legs don't always have to be the same length. Sometimes they are, sometimes they aren't. We'll talk about that here in a second. So the two non-parallel sides are called the legs of the trapezoid. The two angles here are called the upper base angles. And the two angles on the other side are called the lower base angles. So those are all the parts of a parallelogram. The bases are the two parallel sides. The other two sides are the legs. And then you have upper base angles and lower base angles. The upper base angles surround one of the bases, so the two angles that surround this base. And it doesn't matter, upper, lower, this could be turned sideways, so on and so on. They just surround the base. So the two angles that surround that base are on the ends of that base, are those two base angles, then the other two are the other two base angles. In all trapezoids, these two angles are always supplementary, they always add up to 180. These two angles always add up to 180. So one upper base angle, one lower base angle. The two that are connected together on that side, the two that are connected together on that side, always add up to 180. No matter what the trapezoid looks like. Trapezoids could look like the ones that I've been drawing here. Trapezoid could look like this. As long as these two sides are parallel, trapezoid could look like this. These two sides are parallel, so on, so on, so on. There's all kinds of different looking trapezoids. Two sides are parallel, and if this is the case, then these two angles got to add up to 180. These two have to add up to 180. On this one, these two add up to 180. These two add up to 180, or supplementary to each other. Properties of a trapezoid. Trapezoid always has one pair of parallel sides, and the angles surrounding each of the legs are supplementary. They add up to 180. To prove something is a trapezoid, if you prove one pair of sides are parallel, then we can say it's a trapezoid. Special kind of trapezoid is an isosceles trapezoid. Remember, in an isosceles triangle, it had two legs that were congruent. That's the same idea in an isosceles trapezoid. An isosceles trapezoid, you got your bases that are parallel, and your legs are congruent. So those two legs have to be congruent to each other. That's what makes something an isosceles trapezoid. In an isosceles trapezoid, it has some of its own properties. So this only works for an isosceles trapezoid. These are special properties of an isosceles trapezoid. Each pair of base angles are congruent. So the upper base angles are congruent. The lower base angles are congruent. In an isosceles trapezoid, the diagonals are the same length. So the diagonals are congruent. Now you got to be careful. In a parallelogram, or in like a rectangle, the diagonals are congruent and they bisect each other. In a trapezoid, the diagonals do not bisect each other. Mark this on your paper there. But in this, if I put a V here, these diagonals, if it's an isosceles trapezoid, this part and this part are congruent. This part and this part are congruent. So the diagonals don't bisect each other, but they do split each other up in a special way. And then the last one, that makes it an isosceles trapezoid, if these two are parallel, these legs always have to be congruent. prove something is an isosceles trapezoid, if you can show that these angles are congruent, these angles are congruent, then it's an isosceles trapezoid. If you can show that the two diagonals are the same length, then it's an isosceles trapezoid. If you can show that these two sides are parallel and the other two sides are congruent, then it's an isosceles trapezoid. Mid-segment. We talked about mid-segment of a triangle. Remember mid-segment of any triangle? Took the midpoint of this side, and connected them. That was a mid-segment. Same idea for a trapezoid. Mid-segment of a trapezoid connects the midpoint of one leg and the midpoint of the other leg. So if both those are midpoints, then segment MS here is called a mid-segment. And if it's a mid-segment, it's got a couple of properties here. First property, it has to be parallel to the two bases. So all three of these are parallel to each other. And if it's a mid-segment, base 1 plus base 2 divided by 2 equals this length. It's sort of like you're finding the average of the two bases. So you're taking the base, let's say this top base up here, base 1 is 10, base 2 is 20, just something easy. All you're doing here is you're putting in base 1 plus base 2, adding those two together, and we get 30. Divide that by 2, and you end up with 15. This mid-segment has to be 15. So it has to be a length between these two. It's like the average of the two bases. So if I just draw some trapezoid here, doesn't have to look like anything special. I know those two are parallel. If those two are midpoints, that's mid-segment. And I tell you, this is 4, this is 10. Add those two together, 10 plus 4, you get 14. You divide that by 2, and that's 7. This mid-segment right here has to have a length of 7. And it still has to be, that's supposed to be a 7, and it still has to be parallel to the two bases. So mid-segment of a trapezoid. A kite. A kite's sort of the oddball out of all of these. In a kite, the properties of a kite, two pairs of consecutive sides are congruent. It can't be all the sides can't be congruent to each other. It has to be two pairs of consecutive sides. So these two connected together. When I'm looking at a kite, usually what I think of is if I split this shape, so I have two sides and two sides, split it right like that. These two sides are congruent, the two that are right next to each other, and these two sides are congruent. So a kite isn't a rhombus, it's not a square, it's not a rectangle. It's got to be that way. One pair of opposite angles are congruent. If I erase all this, let me erase some of this. So if we look at this, one pair of opposite angles are congruent. Notice these two angles don't look like they're congruent. This angle has to be congruent to that angle. The diagonals, if I draw in the diagonals, they always form right angles. So all four of those middle angles there are 90 degrees. I have all this drawn on there. So M right there, where M is, those are right angles. Should have my symbols on here. One diagonal bisects the other. If you look at this, if I look at these diagonals, notice this longer diagonal here going up and down, it's not being bisected because this bottom part is most definitely longer than this top part. But these two, that one diagonal gets bisected. And I drew all that on there. I should probably erase everything so you can see it a little better. So those two parts in segment NM and segment HM have to be congruent. One diagonal bisects two angles. So the up and down diagonal here bisects that angle, so those two angles are congruent, and those two angles are congruent. These are all properties of a kite. Oops, let's go back. And again, it's a quadrilateral, so just like all the other quadrilaterals, all the angles have to add up to 360 degrees. All right, fill this in. This is what you're sort of looking at. First thing you're going to check, see if something's a quadrilateral. So you're checking all these things. See if it's a quadrilateral. If it is a quadrilateral, and all you got to do there is count the sides to see if it's a quadrilateral. It's got 4 sides. Then you're going to check all these other things. Next thing you might check see if it's a parallelogram. You could use any of those ways that we talked about to prove something is a parallelogram. So you check, see if it's a parallelogram. If it's, or I'm sorry, this is where the rest of the world comes in, because they stick trapezoid in here. They put trapezoid right here. In the US, a lot of times we stick trapezoid out here like it's its own thing. So check, see if it's a trapezoid. If it's got one pair of parallel sides, then it's at least a trapezoid, but then we check to see from there if it's a parallelogram. So if it's got 2 pairs of parallel sides, then we know it's a parallelogram. Once you know it's a parallelogram, you're not finished. You could check to see if it's a rectangle. Remember, it's a rectangle, different ways to prove it's a rectangle. If it's a parallelogram and it has a right angle, then it's a rectangle. But there's other ways to prove it too. Diagonals could be congruent, so on and so on. If it's a rectangle, we don't just stop there. Then we check to see if it's a rhombus. So this is just like a little flow chart here showing you how to go through this. If it's a rectangle, we check to see if it's a rhombus. If it's a rectangle and it's a rhombus, then that tells us it must be a square. So if it's both that one and that one, a rectangle and a rhombus, then it's got to be a square. If it's a rectangle but it's not a rhombus, then we stop right there, and the best name we can give it's a rectangle. If it's a parallelogram and we check rectangle and it's not a rectangle, then we check to see if it's a rhombus. And if it's a rhombus, then that's the best name that we can give it. If we go back up here to the top and we check C and none of the opposite sides are parallel, so it's not a trapezoid, it's not a parallelogram, then we check to see if it's a kite. And if it's a kite, then that's the best name we can give it. And I didn't put this on here, but you could put it on here. Once you know it's a trapezoid, the one other thing it could be is it could be an isosceles trapezoid. And you check to see if it's an isosceles trapezoid by if the legs are congruent or all those different ways that we talked about in the notes. Venn diagram, if we wanted to use a Venn diagram, all these are quadrilaterals. You can check, see if it's a parallelogram. You can check, see if it's a rectangle. Check, see if it's a rhombus. Notice how rectangle and rhombus, they have this middle part here. If it's both a rectangle and a rhombus, then it's a square. Kite could be out here somewhere. It's still a quadrilateral. but it's not a parallelogram. And a trapezoid could have its own circle here. Like this, or it could be its own circle out there. We'll do it that way. Along with all this, you still got to remember all that stuff that we covered in this chapter. All polygons, the sum of the interior angles, sum of the exterior angles. Remember all these formulas. If it's a regular polygon, each interior angle and each exterior angle. Remember, we'd probably rather use this formula than one of the others, than this one, because it's easier. So remember those 4 formulas. And this isn't on your notes, but hopefully you have this down. This is that chart again, to make things a little easier on you, so that you don't have to do the formula for every one of these. You could just look it up on the chart if you have the chart. Also make sure you keep these notes around, all the notes that we've taken today, so that you can look back and say, okay, the properties of a rectangle are this. What do I know if I know it's a rectangle? And so on and so on. Get out the packets. We're going to do problems on the packets.